responders. My name is Cris Aguirre. I'm retired from Miami-Dade Fire Rescue. I worked on the HazMat team for 26 years as a lieutenant. I now work with HazMatIQ, a subdivision of Federal Resources. This video is for the intended purposes of those that have taken the training and need refreshers. Remember, if you don't use it, you lose it. So bring out your charts, the 2013 version, and bring out your NIOSH guide that we passed out in the classroom. If someone's watching the video that has never taken the training, go to info@hazmatiq.com and ask us, and we'll reply and tell you what the training is all about, what we do, and how we can help your team and make it a stronger team and a safer team. All right, today we're running the one that I've ran all my life, everyone out there, the one that kicks my behind, PG rating. And this is the unknown. So I get dispatched on an unknown. It could be a derailment. It could be an odor. It could be some type of nuisance call as far as people smelling something in a community. But you have no information. So you can't go to the ERG, you can't go to the NIOSH, you can't call Camtrec, you can't call Canutech. This is an unknown. You're on your own. Now you got to remain safe and you got to keep your crew safe. So let's go to chart. Let's see how HazMatIQ can help us and support us in the call that all of us gets, the unknown. It could be a liquid coming out of a drum in the middle of nowhere. We go to chart number 2. It says at the very top, is the first name of your chemical listed below? You go down to use. I see uranium. I don't see unknown. So the answer is no. I go to the no arrow. And then all of a sudden, I know exactly how the unknown looks. Worst case scenario. Remember, this is done under the same mantra as every chest pain is a heart attack until proven differently. So we go, this is above the line. That's a look at the SOP. This is my starting operating procedure, my safe operating procedure. As of right now, that unknown is a gas. The initial hydrogen is 300 feet. The vapors are heavier than air. Those vapors have an LEL and a UEL. They have a flash point. They're flammable. There's carbon and hydrogen. They polymerize. There's an ionizing potential. It's an acid gas, pH red. That acid gas has fluorine, F paper yellow. It's radioactive. It's toxic in parts per million. It's water reactive and air reactive. So everything to the right of a bullet is a physical, chemical, or toxicological hazard. It's an all-hazard response. Everything to the right of an arrow is the instrument that measures that physical chemical property that you can't see. You can't see LEL. I need an LEL sensor because LEL kills. Now we go to chart 3. The last bullet on that box, the above the line safe operating procedure, says continue on chart 3. We go to chart 3 and we realize that since this is a naming chart, that I can't say anything but the answer no to the flammable char box. It's this box in the left top that starts with a set. So it's an unknown and I say no. I go to the middle box, which is the flammable gas clue box, and I say no to that, and it takes me to red 1. I turn over to my crew. This above the line has become a red 1. All units responding, red 1. Everyone gets their charts that's responding to the call, and they know exactly how chemical looks. Exactly. This is an unknown, all hazards, including WMD, water reactive, air reactive, and it polymerizes. Bring all the meters in. Notice that all the meters are X'd. Now you don't know which ones are going to hit, but when they do, if they happen to be in a red column, remember that's the safe kit. That means that there are 5 hazards out there that can kill me, that I can't see. Radiation, fluorinization, corrosivity, polymerization, and also exothermic reactions, and flammability. This is this kit, a kit that we designed called the Safe Kit, the Stay Alive 5. Rad, F, pH, LEL, temp, right here. If you want information on that, just contact us at info@hazmatiq.com, and we'll shoot you out the information for it. It's catching on around the country. If you got a hotel pack, if you got a med pack, if you got a life pack, if you got a trauma pack, you need a safe pack. We go to red 1, and we see that all hazards, and I'm going to wear turnout gear because I'm a firefighter. Those guys in the military, multi-threat suit, level A, level B. Remember when you were a level A? Rescues aren't made in level A. Plumbing is. Site exploitation is. But not level A. Takes too long to get into. I can't go to the book. If I can't go to the book, then I can't whittle down the hazard. So it means this. When I get a name, I can identify the hazards in the cold zone. When I don't get a name, I need to send someone in there. Like they say in the military, I need someone to go down range and do sensitive site exploitation to bring back the data to make a decision. So for example, let's go by each meter. If I go in there and the radiation is above 2 background, gamma, 2 times background, it means that this is a red light. It should not be 2 times background on gamma. I need to back out and find out what, maybe bring an isotope identifier in. This might be something you might not have. You might need to know who has one. If you have a rescue to be made, quick in, quick out. Let's go to the next column. The next columns are 2 sets of paper, 1 pH and 1 F paper for fluorine. If you go to chart 1, look at element number 9. It has 2 colors. The predominant color is red because pH paper turns red in a fluorinated corrosive gas. And the F paper turns yellow. The strip of F paper turns yellow if there's F in the formula. We don't know there's F in the formula. It's an unknown. Remember what fluorine does to you. Hydrogen fluoride, fluorine, 1%, the size of your palm. Could be an LD100. We go to the temp gun. We shoot the background. The background is, just like in radiation, the background is in the cold zone versus downrange. The background is the temperature of the ground where the spill is. I shoot the temperature of the ground. I'm in Miami, Florida in August. It's 142 degrees. I shoot the containers. It's 142 degrees. There is no exothermic reaction. If that is rapidly rising, that is a red light and we get out. I look at the CGI. Has the O2 been depleted? Does it say at 21%? If it goes down just 0.1%, you're looking at 5,000 parts per million of something else in the air. Is the LEL at 0 or is it going up? Notice that right above CGI, it has 2 numbers, 10% and 1%. The red light, which is the get out level, unless you have a line of sight of safety, a line of sight rescue, is 10% of the LEL. If you're in plastic, it's 1%. You don't want to stay there more than 1% if you're not going to save a life in a plastic suit, because it's too hazardous. Change the environment. Look at the 4 levels of dress at the very right. Each one of them has a different level of dress, a different red light. 10% for turnout, 1% for plastic, and notice that the other one, an F paper goes yellow. So if I have a line of sight rescue and the F paper doesn't turn yellow, quick in, quick out. F paper turns yellow, I leave, come back in a level A. And when I come back in a level A, F paper and pH paper on the outside of the visor and on the inside of the visor, because about 95% of the loss of integrity on a level A suit is downrange, in the hot zone, behind me. All right, guys, so if you want any more information on the Safe Kit, on some training that we do, please contact us at info@HazMatIQ.com. And until the next time we meet, my fellow responders, may all your lights remain green.